Hey guys, today is May 24th. I haven't recorded the code problems in a while, but let's just do one for fun. Um, okay, this is a medium. Longest palindrome by concatenating two-letter words. Okay, this sounds pretty tricky. You are given an array of string words. Each element of words consists of two lowercase English letters. Create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. Return the length of the longest palindrome that you can create. If it is impossible to create any palindrome, return 0. Oh, wow. Um, I think this is a little bit tricky. I think we can leverage the fact that we are guaranteed that each word is length 2, right? And then maybe this becomes some sort of like counting problem. Like for example, like this first one, right? Like if these are our words and we know that we have an LC, that means in order to find a palindrome with LC, we need to combine it with CL, like it's opposite. Um, I don't know how I would count it. Maybe like LC appears once. And then we could check. Then we could check, hey, is CL in this like map or whatever? And then we'll see that it does appear once. So what are we doing? We're returning the length. So we know that this length is 4. Now, what if there was two LCs and then there just so happens to also be two CLs? Doesn't that mean we can do LC, LC, CL, CL? Yeah, so as long as the minimum of these two is what we can use. The minimum of those two is how many we can use. Right? So like if there was 4 CLs and only 2 LCs, LC, LC, CL, CL, that's it. We can't just all of a sudden put a CL right there. Yeah. So then we're bound by the minimum occurrence, I guess. And then if we don't use everything, I guess we could always put a GG, or we could always put like something in the middle. It's kind of tough, is it not? Okay, so let me just run through my idea again, but this time with this. We have AB appears once. We have TY appears once. YT appears once. LC appears once. CL appears once, and AB appears twice. So just run here and say, hey, does BA exist? It doesn't. So we move on. So this didn't work. Now we'll move on to this one and say TY, does YT exist? It does. So we're just going to take the minimum of these occurrences, which is 1. So we're going to have 1, but then each letter can each word has 2 letters, so it's going to be 1 times 2 plus. So we just handled this. So since we dealt with ty and yt, we should probably like put them in a set so that we never come back, right? Because the next iteration we'd check yt and we don't want to recalculate that. So then we'll move on to LC, and then we're going to say, okay, do we see a CL? We do. Let's take the minimum occurrence, and that's the minimum occurrence is 1. So then we're going to do 1 times 2 again, and then we're going to like put those in the set so that we don't have to double count. Maybe we can multiply by 2 later. So for now, I'm just gonna, so like you see the times 2 and the times 2, so I'm just gonna like bring that out. I'm gonna say 2 times, and then these are all of the like minimum occurrences. So it'd be like 1 for that like TYYT occurrence, and then for the LCCL occurrence, it also appeared once. And then since we're keeping track of this, I could also say that like let's just say the ABs weren't there. This would be 4, right? So this would equal to 4. If the length, okay, so let's just call this the result or whatever. So that if the result is less than the length of the words, like how many words there are, see how there's not, res is 4, even though there is 1, 2, 3, 4, 5, 6, then that means we can go ahead and oh oh wait, is it like that? Take the minimum occurrence. Oh, 2 because we're using ty and yt, but then we have to multiply by 2 again, so we might as well just do 4 times. Yeah, I kind of messed up there. So it's actually 4 times 2, which is 8. But this is interesting. The only thing I'm curious about is like if there was a GG, then we would actually be able to fit a GG like in the middle. So it's actually something very specific that we're looking for. We want a same letter word, right? For example, GG, which would be perfect, and we want an odd number of appearances to use in the final result. So I guess it could just be like a bool odd same is equal to false, and then we're just going to try to find that. So if odd same, then we can return the res plus 2 because we'll just add the odd same 2 letters to the middle of the palindrome. Oh, and then what about this one? CC, so we're looking for, okay, if it's CC, so if odd same, we need, yeah. So the odd same is kind of special. It's like a special case because we're not looking for the reverse because the reverse is the exact same. We'll just do the calculation right then and there. So that's a separate case, I guess. So res is 0. We're going to have a bool odd same, this false. We want to look at each word in words, and even more than that, for C1, C2, print C1, C2, because I don't know if this actually works. And then we're just going to return int, right? So return -1 for now. Let's see if this runs. Okay, that works. But actually, I'll just say for W merge, C1, C2 is equal to W. One sec. Okay. So, and then I wanted to do that thing where used is just like a set of all the things that we've already used before. So if word in used, then just continue. If W is already used, continue. Okay, so now we haven't used this before, so we're just going to do use.add W, like that word. And then we also want use.add C2 plus C1, right? Like the opposite of it. And then, like I said before, we also want a counter of words. Did that work? Sorry, I'm a little bit rusty. Let me print C, see what happens. Yeah. Okay, it'll count for us. That's pretty good. So we just want to keep track of the frequency of each word. So now we add it to the thing. Okay, so if C1 is equal to C2, so this is the case where the two like letters are identical. If the two letters are identical, let's check the frequency if C at W is greater than 1 and CW mod 2 is equal to 1. If it's odd, then odd same is true. We can use that later. I might go like this. If it's greater than 1, that means it's at least 2. So we can divided by 2. So if there's 2 occurrences, that would be 4 letters. Res plus equal to 4. What if there was 5? If there was 5 of them, we can use, if there was 5 of them, we can use 1, 2, 3, 4, 5, 6, 7, 8. 5 divided by 2 times 4. So it would be CW divided by 2 times 4. Does that make sense? If there was two of them, it would be 2 divided by 2, which is 1 times 4. So there'd be 4 letters. Yeah. Okay. I think that's good. And then, like, what happens if it just appeared once? Okay, then I need to take this out. If this is equal to 1, odd same is true. If CW is greater than 1, then we can actually add it to our result. Yep. And then later, before I forget, if odd same, then we can actually return res, the result plus those 2 letters that we put in the middle. Otherwise, we just return res. Okay, pretty good. That was just a very special case. Otherwise, we want to check the opposite, right? So min of C. Okay, what if it's not in there though? So the reverse is equal to C2 plus C1 if rev not in. If rev in words, if the reverse is in words, then we can do the min C of W or the frequency of that reverse. Whatever's smaller, we just add that to res times 4, right? Isn't that what I said before? Times 4. 4 times the min of that. Like if the reversed and the thing just happened once, the minimum was 1, then it would be 1, 2, 3, 4. So that'd be 1 times 4. So our result would have 4 new characters in it. I think that makes sense. Other than that, I think that's it. I feel like this was very not good. Like I made it very confusing, but hopefully this runs. Just kind of cleaning some stuff up. I don't see why this wouldn't work. Let's go ahead and submit. Okay. Interesting, there's not even, why am I putting 14? There's not even that many in there. Oh, I'm double counting the used, right? No. Oh, I say if here, and then I still do the reverse of the thing. So if they're the same, so this is if, else, and then just shift everything in there. So like, this is the case where 2 letters are identical, and then this is the case where 2 letters are different, right? It's kind of funny. Okay, that works. Let's go ahead and submit. Nice. Yeah, like I haven't been like focused on the code like grinding recently, but I'm at that like level where it's interesting. Like I feel like I don't have to think super hard. I'm kind of just like floating at, I'm just kind of like existing, and my ideas can turn into code like slowly, but I could do it. Whereas in the past, like I would have an idea, but then I would be like, oh, that's way too hard, or like I'd have to look at a solution or hint. I'm pretty happy at where I am right now. I like, but I'm plateauing. Like I was definitely better when I was grinding, and I know I could be better at leak code, but I'm just kind of floating in this like, oh, I have an idea. Like I have an idea and I can execute it. So I'm pretty there's the positive in whatever that is right now. But I mean, this took me like what, like 18 minutes to do. I feel like it should have been like a little bit faster, and I didn't explain it super well. But I guess that's just like the practice part of it, which I'm out of touch right now. But yeah, this problem's not that bad. Is the what's the topic? Yeah, array, hash tables, string, greedy, counting. Yeah, it's like those counting problems. Um, that's fine. I guess the hardest part is just realizing that there's mainly two cases when the letters are different and when the letters are the same. Then we can use tricks like a like counter, right? Like a frequency counter. We can use like a scene set so that we don't double count. Um, and then I guess some like counting tricks like times four, some things that we need to realize. And then also like maybe some like we have to realize that when we find the opposite of a word, we can only use the minimum of the frequency, the minimum of the two words frequency. We can multiply that by four, and that's all that we can contribute to our result. And then just keeping track if there was an odd number of a word that had the two same letters. That's very important because if there was an odd number, we can take that like odd we could take one of them because it's odd, right? So we'll take one of that word and just jam it right in the middle to maintain the palindrome. Okay, it's a lot of talking. Let's see the time and space complexity. So time, I definitely see linear right here, but then linear, right? Adding to a set time complexity. I'm kind of rusty on this. Is it? Oh, I guess it's O of 1. Oh, it's O of 1. Okay, so it is linear. Oh, running counter on a list time complexity. I guess O of n. Yeah, sorry, I'm a little bit rusty on that. Space is also O of n because especially we're doing the counter, we're doing a used set. Yeah, but I guess this is just a linear solution. So hope you guys enjoyed the video and thanks for watching.